Hello, welcome to the podcast, screencast in this case, screencast. Hi, it's Mass. You should know. Today we're going to be talking about quadrants. We're going to be talking about coordinate planes, and we're also going to be talking about reflections across axis, which sounds a little evil, a little scary, but it's really not all that bad. I think our very first step should be let's take a review of what a coordinate plane is. There's a picture of one right here. In all its glory. It has a couple components that are really important to what we're doing. We'll start with the very beginning, the origin, and where we always start counting, which is right here. It's called the origin. It's 0, 0. When we start talking about coordinate pairs, that's exactly where we start. We have an axis that goes horizontally. That's called our x-axis, and a vertical axis called our y-axis, and they're linked up alphabetically. X comes first, then y, and let me show you why. If I have a coordinate pair, a pair of numbers, let's do something kind of simple. Let's go 2, 3. I have a graphable pair of numbers that start with x and end with y. What does that mean? All right, starting at our origin, we're going to start right here. I'm going to count over 1, 2. 1, that's the axis now, and then 3 on the y-axis, which is this axis that goes this way. 1, 2, 3. So right about there is our new point, or the location of 2, 3 is right here, and it's in quadrant number 1. If you would fall over into this quadrant, that's quadrant number 2, quadrant number 3 right here, and quadrant number 4. Okay, let's take a look at, let me just do a little bit of erasing. A little bit more complicated, there we go, coordinate pair. We've been talking in 6th grade about integers and negative and positive. So let's talk about negative integers. Oh, way too big. Oh, -3, -4. You know exactly what that looks like on a number line. It's the left side of the 0. In this case, the left side and then downward. So first comes x, start our origin and count -3. 1, 2, 3. And then our y-axis is says -4. I'm going to go down 4. 1, 2, 3, and 4. So I could say that the ordered pair -3, -4 is in quadrant number 3. Mathematic shortcut. If you have a coordinate pair that's positive and positive, like our first example, you're going to end up in quadrant number 1. If you have a pair that is a negative and then a positive, you're going to end up in quadrant number 2. A negative and a negative coordinate pair, you're in quadrant 3. And then a positive, then a negative. Oh, that's a perfect positive symbol. And a perfect negative, yeah. You're in quadrant number 4. Let's move forward to this whole business of reflecting. Okay. Here we have a coordinate pair already mapped out for us. I'll make it a little bit bigger so we can see. It's the ordered pair -3, 2. Why is that -3, 2? We start right here at the origin. What? 1, 2, 3. I went -3 and then +2, and I arrived at that coordinate plane. Question. What quadrant is that in? If you guessed quadrant number 2, you're absolutely right. That is quadrant number 2. The question, though, has nothing to do with that quadrant. It has everything to do with reflecting. Now, when I think of reflecting, I think of maybe reflecting in a mirror, or maybe looking into a glass of water and seeing a reflection. And there's not much difference here. We're going to take a look at this case. It says across the x-axis. Remembering that the x-axis is this one right here. Pretend I'm holding a mirror up to the x-axis, and we're going to reflect across the x-axis from this quadrant down to that quadrant, because this is the x-axis we're coming across. The way I think of it is I'm still going to come 1, 2, 3, -3, except I'm not going to go +2 this time. I'm going to go 1, 2, -2. So I would say the reflection of -3, -2 is -3, -2. Some people today in class quickly caught on that if I'm reflecting across the x-axis, I'm changing the y-coordinate, and the other way around. That if I'm reflecting across the y-coordinate, I'm changing the x-coordinate. Let me just show you what that means too. What if the problem asked me to reflect across, instead of the x-axis, a pen to write with, the y-axis? All right. In our last example, we looked at the x-axis and we reflected across that, like it was a mirror. But this time, we're looking at the y-axis. So we're going to be reflecting across that direction into, well, our first quadrant. Now I noticed that the very first number is -3, so I'm going to go +3. That would be the opposite. And then 1, 2. So our ordered pair, -3, 2, reflected across the y-axis would be +3, +2. And using my mathematics or my reasoning, I changed to reflect across the y-axis. I changed the x component of our coordinate pair. That's reflecting across the axis. That's coordinate planes. Please feel free to write questions or even some comments about what we're doing here on the screencast. Hope that helps, ladies and gentlemen. Have a great evening and take care.